Okay guys, we're going to be working through the note packet that is titled Angle Measures. If you were at school those last couple of days before we went on this long break that we've been having, you were given a packet. You will find this note page in that packet. If you were not at school, I have uploaded this note packet into Google Classroom. So you need to either print this packet if you have that capability, or you need to make sure that you are writing these notes down on your own paper. Feel free to pause this video at any time if you need a little bit extra time writing anything down, and then you can always play it once you are caught up. Okay, so we are going to be finding a lot of things in this first note packet. This one will be one of our longer ones of all of the packets in this unit. So the first thing that we need to work on is being able to convert angles from degrees to radians and radians to degrees. These are both ways that angles can be measured. You're probably most familiar with degrees, but radians is another measure that does exist. In higher math courses, you will be using radians a lot more than you will be using degrees. So here are the two formulas that you will use to convert degrees to radians and to convert radians to degrees. So all you do is take your degree and you multiply it by pi over 180 degrees. You simplify that and you have your answer. If you're given a radian measure, you will know it's a radian measure because it doesn't have the little degree symbol. So if you were given, let's say, 35 degrees, this is obviously a degree because of this little symbol here. But if I just gave you 35 and there was not a degree symbol there, then that means that that is 35 radians. So that's the difference. A lot of radian measures has pi with it. So what you would see instead of the degree sign would be to see like a pi symbol sitting next to that 35. So once you know that it's a radian, you just multiply it by 180 degrees, divide that by pi, and that will give you your degree measure. Okay, so that's our front page of that first packet. I'm going to go ahead and turn to the next page. So this is what you should see: convert each degree measure to radians, and then we're going to convert each radian measure to degrees. You're definitely going to want to have a calculator close by. You'll hear some clicking in the background. That's going to be me using my calculator for some of these conversions. So since this is a degree, obviously because there is a degree symbol from the previous slide, you're going to multiply that by pi over 180 degrees. Okay, so you have a degree on the top of the fraction and you have a degree symbol on the bottom of the fraction. Those degree symbols are going to cancel each other out. So you have 135 pi over 180. So now using your calculator, you want to put in 135 all over 180, and it simplifies to be 3 pi over 4. So that means that 135 degrees is the same thing as saying 3 pi over 4 radians. We're going to do the same thing on this next one. So since it's a degree, we're going to multiply it by pi over 180 degrees. The degree symbols cancel. So that would leave us with negative 570 pi over 180. Again, plugging that into your calculator, negative 570 divided by 180 is negative 19 pi over 6. So negative 570 degrees is the same thing as saying negative 19 pi over 6 radians. Now we're going to go the opposite way. So this time we're given radians. We know the radians because there's no degree symbol on either one of these problems. So from the previous slide, we're going to multiply by 180 degrees over pi. This time the pi's are going to cancel each other out. Up here the degrees did, here the pi's are. So we're going to multiply 7 and 180. And that gives us 1,260, and that's going to be divided by 6. So our answer is 210 degrees. So 7 pi over 6 radians is the same thing as saying 210 degrees. Same thing on this next one. There's no degree symbol, so that's how we know it's a radian. So we're going to multiply this by 180 degrees and divide that by pi. The pi's are going to cancel, so we just need to multiply -12 and 180, and we get -2,160. There's nothing for us to divide by here, so we just need to add our degree symbol. So -12 pi radians is equivalent to saying -2,160 degrees. So one of the things you're going to be asked to do in your assignments is to make sure you can do these conversions. Okay? The next slide, you'll see an angle is formed by 2 rays that have a common endpoint. One ray is called the initial side and the other ray is called the terminal side. An angle in standard position, its vertex is at the origin of the coordinate plane and its initial side lies on the positive x-axis. I want you to think about this for a second. If I were to draw a circle with a center, and I drew in a radius, and then I drew in another radius someplace, I have formed an angle. Now think about this circle sitting in a coordinate plane. So here's your initial side that sits along the positive x-axis. Here's your terminal side where the angle ends, and you need to make sure that you show this rotation because as you can see right here, positive angles rotate counterclockwise. That's what we did here. So counterclockwise is going the opposite of the direction that a clock travels. So we traveled clockwise here. Negative angles rotate clockwise. So if I wanted to draw a negative angle, I would still start here, but I would travel in this direction instead. Again, make sure you show that rotation because if you just drew this without this little direction here, nobody knows if you traveled in the positive direction or if you went all the way around and traveled in the negative direction. So you need to make sure to show that rotation. So now what we're going to do is exactly that. So if you flip to your next one, we're going to draw each of these angles in standard position. It's very difficult to understand how to draw an angle when it's in radian measures. So using the skills from those previous examples, we're going to multiply this by 180 degrees and divide it by pi. Again, pi's cancel, so in your calculator you can take 4 times 180, divide it by 3, and now we know that this is 240 degrees. Okay, so our initial side starts right here along the positive x-axis. You just want to highlight that, make sure it's nice and bold. And it's a positive angle, so we're going to travel counterclockwise. So we're going to start anywhere on this line. We're going to start traveling. Now, when I move, know that when you get to this point here on the positive y-axis, that's 90 degrees. We're not there yet because we need 240. So now we're going to travel down to the next line. That next line is 180 degrees, so we're still not there yet. If I go to the next line, that's going to be 270 degrees. That's more than what we want. So 240 is going to be a little bit before 270. So approximately right there is your terminal side of your angle. And again, make sure that you show the direction that you traveled so they know that it was either positive or negative. And that's how you draw an angle in standard position. Another thing that you'll be asked in your assignments is which quadrant does the angle sit? And we'll be seeing this a little bit later in another, the second part of this video, but just remember that this is quadrant 1, and then it travels counterclockwise just like a positive angle, quadrant 3, in quadrant 4, so this angle would be in quadrant 3 because that's where its terminal side is. And then you're going to do the same thing for the next 2 problems. So I'm going to first convert this to degrees, so multiply by 180 over pi. So I'm going to take -5 times 180, and I'm going to divide that by 6, and I get -150 degrees. So I'm going to start on my positive x-axis, no matter what. You always start there. Now our angle's negative, so I need to travel clockwise. So if I start on this initial side, I travel down to that first line, that's -90. If I go up to this next line, that's going to be -180. That's too far because we only need to go to a -150. So we're going to say it's approximately right there. There's your terminal side. Finish drawing the rotation so they know which direction you traveled, and you've got your angle, and that as well sits in quadrant 3. This last one is bigger than 360. It doesn't matter. It's already in degrees for us, so we don't have to worry about converting it. So I've got my initial side. So if I travel all the way around, that's 360 degrees. So I'm going to have to go another rotation. Let's see how much more of a rotation. If I were to subtract 360 from 690, it equals 330 degrees. So I've already traveled 360. Now I need to travel another 330 degrees. So I'm going to travel all the way around again. So I'm at 90, 180, 270, 330 is right before you get to 360 again. So there's my terminal side. Make sure you show that rotation so they can see exactly how you traveled. So that's part 1. When you're ready, you can click on the second link to see the second part of these notes.